Hi, in this video I'm just going to go through organohalogens and the environment. Organohalogens, first of all, just give a definition of what they are. They're just any carbon compound that also contains a halogen. So a simple one would be chloromethane. We can get more complicated ones, such as difluorodichloromethane. There can be much longer chains than that, but we get an organic compound that also contains some halogen groups. And they're important because they damage the ozone layer. Now, the ozone layer is an area in the atmosphere made up of ozone, hence the name. Ozone is O3, so it's a atomic molecule, all of oxygen. In the ozone layer, we've got a very delicate equilibrium going on, and that involves oxygen breaking down into oxygen radicals. So we've got O2 molecule breaking down into two oxygens, and then that more O2, reacting with an oxygen radical in an equilibrium to form ozone. So ozone's constantly being formed and broken down and formed and being broken down, and it's a really, really delicate equilibrium that maintains it up there, and we get protection from harmful UV rays. Now, the danger we have is when these two things combine, and what we get then is a radical substitution reaction that breaks down the ozone and just forms more oxygen and damages this equilibrium. And what we see, if we go for the mechanism for breakdown, I'm going to start with CF2Cl2 with UV light. Should be familiar to you now what happens with UV light when we've got halogens. We're going to create radicals. So just in this separation, I'm forming sort of a weird halogen methane radical and a chlorine radical. So that's our first initiation step. Then we have a propagation step, and that chlorine radical reacts with ozone. And what it creates is, most importantly, oxygen, but also a CLO radical. So this oxygen is going to be important. That CLO radical can react with the oxygen atoms that we know are floating around up in that equilibrium, up in the atmosphere, and create our original chlorine radical. So we've got a catalyst here, plus two oxygens combining together to form O2. And that overall equation for this reaction, the chlorine radicals cancel out and the CLO radicals cancel out to give us O3 plus O goes to 2O2. So we're breaking down this O3, O2 and O and just forming oxygen, which breaks down the ozone layer. We're getting less and less ozone there. This is a very similar mechanism to one you've already seen for alkanes reacting with halogens. The other way, you might get asked about and might see this mechanism, is a very similar one to this, but doesn't involve an organohalogen. In fact, uses nitrogen oxide radicals. I'll just put a note on this. Is one that has appeared in exam questions. It's the same sort of mechanism, follows the same pattern as before. NO radical plus O3, you can probably guess following the pattern up there what this is going to form. Definitely O2, and if we've lost an oxygen from there, then we're going to get the NO2 radical now. That NO2 radical is going to react with oxygen to go back to our original radical plus another O2, and that follows the same mechanism. Sorry, the same overall equation then. So this is our organohalogens in the environment. These mechanisms you have to know and could get asked about